A flatbed truck rolls up to an empty patch of land. On the back, not a house, a cube, a single, flat, closed cube of timber, no bigger than a shipping container. Watch this. That box right there. In 3 hours, it's going to become a fully livable home. Kitchen, bathroom, bedroom, electricity, plumbing, all of it. No foundation, no concrete truck, no construction crew hammering away for 6 months. Just 2 people, a small crane, and a house that unfolds itself like a piece of paper. Time lapse. Walls swinging outward, a roof lifting and unfurling, the cube nearly doubling in size in seconds. This isn't a concept render. This isn't a Kickstarter promise that never shipped. This is happening right now, in 2026, and it's part of a much bigger shift in how humans are starting to think about the buildings we live in. Buildings that don't just sit there, buildings that move, buildings that fold, flex, and reshape themselves around us. They're called kinematic structures. And today, we're going deep into the strangest, smartest one of them all, the origami tiny home. Before we get into how this thing actually works, and trust me, the engineering behind that folding hinge is wild, hit that subscribe button right now. This channel is where we track the buildings, machines, and spaces that are quietly rewriting the future of how we live. And if strange, brilliant architecture is your thing, you do not want to miss what's coming up on this channel next. Subscribe? Good. Let's get into it. Okay, so let's back up for a second because kinematic is one of those words that sounds like it belongs in a physics textbook. And honestly, it kind of does. Kinematics is the branch of physics that studies motion, how things move, rotate, fold, and shift position, without necessarily worrying about the forces causing that motion. For centuries, we've applied kinematics to machines, engines, robots, elevators. But architects and engineers have started asking a very different question. What if we applied the same principles to buildings? What if a wall could fold flat when you didn't need it? What if a roof could unfurl like a sail? What if an entire home could compress down to the size of a shipping container for transport, then expand into a full-sized living space the moment it arrived? That's the world of kinematic architecture. And nowhere is it more visible, more almost magical to watch, than in the world of origami-inspired housing. Origami, the Japanese art of paper folding, might seem like an odd place to look for housing solutions. But here's the thing engineers figured out decades ago. Origami isn't just an art form. It's a mathematical system for turning a flat, compact shape into a complex three-dimensional structure using nothing but folds along calculated lines. No extra material, no waste, just geometry doing the heavy lifting. Split screen, a paper crane being folded next to a timber wall panel, swinging open on a hinge. Engineers have used these exact folding principles for things you'd never expect. Deployable solar panels that unfold in space. Emergency shelters that pack flat and pop open in disaster zones. Even medical devices. Tiny folded structures that expand once they're inside the human body. The scale ranges from nanotechnology to spacecraft, and now, increasingly, to housing. So when someone builds a tiny home that folds and unfolds like a piece of origami, they're not just doing something cute for social media. They're applying real, tested engineering principles to solve a problem that has plagued the housing industry forever. How do you build something strong, comfortable, and permanent that can also move? Now, there's one company that's become the poster child for this entire movement. And honestly, once you see their product in action, you'll understand why it went viral the moment it launched. It's called Brette Haus, a startup based out of Riga, Latvia. Their pitch is deceptively simple. A home that arrives on the back of a truck as a closed, compact cube and unfolds into a full living space in as little as 3 hours. The founder, Æqua, described the process in a way that stuck with a lot of people. Building one of these homes is basically like playing with Lego. You have separate, precisely engineered parts. Brette Haus assembles them at the factory, folds the whole thing down into a transportable shape, ships it to wherever you are, and then plays Lego on-site, unfolding it into a home that's ready to move in almost immediately. Founder walking through a factory floor stacked with CLT panels. Here's what makes this more than just a gimmick. Brette Haus isn't claiming to have invented the concept of a folding house. Fold-out structures have existed in various forms for years. What they say they did innovate is the mechanism, a patented hinge system, engineered specifically to survive the incredible structural stress that folding and unfolding puts on a building. Think about it. A normal house never moves. Once it's built, the walls stay exactly where they are for the rest of its life. But a folding house has to endure the physical stress of opening and closing over and over, without the joints failing, without water getting in, without the structure warping. That's an entirely different engineering problem than traditional construction, and it's one that's taken years, and reportedly more than a dozen patents either secured or in development, to solve. The company backs their hinge system with a guarantee of at least 100 full folding cycles. That means, in theory, you could fold and unfold this home over 100 times across its lifetime, and the mechanism should hold. For context, most people are never going to fold their house even a dozen times. But it tells you something about how seriously they've engineered the joint that makes the whole concept possible in the first place. So how does a rigid timber building actually fold without cracking apart? This is where it gets genuinely fascinating. Picture the home in its shipped, closed state, a tight, compact cube. Inside that cube, hinges run along the floor and along the roofline. When it's time to install the home, a small crane lifts one section, and a hinge along the floor allows one entire side of the structure to swing outward, like a book opening. At the same time, a separate hinge system along the top lets the roof unfurl and rise into its final peaked shape. Diagram animation, floor hinge, roof hinge, walls swinging into position. This isn't a minor expansion, either. According to the company, their space-doubling system can increase the livable area by as much as 149% compared to the home's folded, shipped size. In other words, what arrives as a small, dense cube on a trailer can nearly double in usable floor space once it's fully deployed. That's the entire point of the origami principle. Maximum compactness for transport, maximum volume for living. Now, folding is only half the engineering challenge. The other half is what the house is actually made of, because a folding structure puts far more stress on its materials than a house that just sits still. That's why Brette Haus builds almost exclusively with cross-laminated timber, commonly known as CLT. If you're not familiar with it, CLT is basically timber engineering's answer to plywood, but on a massive structural scale. Layers of solid wood are stacked at right angles to each other and bonded together, which cancels out the natural weaknesses of any single plank and creates a panel that's incredibly strong in multiple directions at once. Regular timber frame construction, or lightweight steel framing, simply can't handle the repeated stress of folding and unfolding. The joints would eventually fatigue and fail. CLT's cross-grain structure gives it the rigidity to survive that stress cycle after cycle, while still being light enough to transport and lift with a small crane instead of heavy construction equipment. For insulation, the company uses fiber boards made from sawmill byproducts, sawdust, wood shavings, offcuts, pressed together using the wood's own natural binders activated under heat, with no synthetic adhesives involved. The result is an insulation material that's compostable, absorbs carbon dioxide, and, maybe most importantly for a wooden building, chars instead of igniting when exposed to heat, which helps with fire resistance. And that fire resistance isn't just marketing language. These structures are built to meet a fire resistance rating known as REI 60, meaning the structural elements are designed to maintain their integrity, insulation, and load-bearing capacity for a defined period under fire exposure. Combined with a build designed to withstand seismic activity, these aren't flimsy pop-up shelters. They're engineered to hold up as genuine, code-conscious housing. Alright, so the folding mechanism is impressive. The materials are serious engineering. But what does it actually feel like to live in one of these things? As of 2026, Brette Haus offers a small lineup of distinct models, each aimed at a different use case. Interior walkthrough, kitchen counter, compact bathroom, ladder to sleeping loft. There's the Rustic line, their flagship, most traditional-looking model, with a classic peaked roofline and warm timber tones. This is the one most people picture when they think tiny cabin. It's the model built for private, residential living, a real, comfortable home, just one that happens to fold flat. There's Tiny D, developed in partnership with a hospitality-focused design studio, aimed squarely at Scandinavian-style retreats, garden offices, and short-term rental setups. It leans harder into aesthetic polish, built for people who want their tiny home doubling as a design statement, whether that's a backyard guest house or a boutique hospitality unit. And then there's Æqua, a completely different animal. This one isn't a full living unit. It's a foldable outdoor sauna and modular wellness block, designed to slot into hospitality projects, spas, or private wellness landscaping. It shows that the folding technology isn't limited to full-blown houses. The same hinge and CLT system scales down into recreational and wellness structures too. Inside the residential models, you're typically looking at LED lighting, full electrical wiring, a shower, a toilet, and a kitchen area with a countertop and sink as standard, with upgraded finishes and a full kitchen available as a premium option. A sleeping loft, usually accessed by a ladder, tucks under the roofline to maximize the small footprint. And crucially, all of the sanitary and electrical systems are pre-installed at the factory before the home ever ships. So what unfolds on-site isn't a shell you still have to wire and plumb. It's close to move-in, ready from the moment the last hinge locks into place. For anyone wanting to live fully off-grid, there are optional add-ons too: solar battery kits, water pumping stations tied to sewage modules, everything you need to place one of these homes somewhere with zero existing infrastructure. Now here's the part that surprises most people when they hear the price for the first time. Because you'd assume something this technologically advanced, patented hinges, aerospace-adjacent folding engineering, custom CLT construction, would cost an absolute fortune. It doesn't. Not compared to what you'd think. Pricing on these homes generally starts somewhere in the range of the high teens to low 20s and thousands of euros for the smallest configuration, with larger, more fully appointed models climbing up toward the €50,000 mark, depending on size and finish level. Sizes across the lineup range from smaller units around 18 to 20 square meters, up to larger multi-room configurations, well over 100 square meters for bigger, family-oriented designs. For context, that starting price point puts a fully wired, fully plumbed, factory-finished tiny home roughly in the same territory as a nicely spec'd car, for a structure that could, depending on where you live, function as an actual legal residence. Now, it's worth being honest here, because a responsible breakdown of any product should include the fine print, not just the highlight reel. Manufacturing lead time typically runs 8 to 12 weeks, depending on how busy the factory is when you order. This isn't something that shows up next week. Once it arrives, installation itself is fast, generally 3 hours up to a full day, depending on weather conditions and how accessible the site is for the crane and delivery vehicle. But you do need clear vehicular access to wherever you're placing it. This isn't a house you can helicopter into a remote mountainside with no road access. The company backs their build with a 2-year warranty across all structural elements, and states that, with proper care, a timber structure like this can be expected to last 50 years or more, which is very much in line with well-built conventional timber housing, not some experimental short lifespan gimmick. And then there's the fold cycle guarantee we mentioned earlier, 100 cycles on the hinge system. For the vast majority of buyers who might relocate the home once, twice, maybe a handful of times over its lifetime, that ceiling is functionally a non-issue. But it is worth knowing that the hinge, however brilliantly engineered, is still, at the end of the day, a mechanical wear part, not something with infinite lifespan. So who's this actually for? Because a house that folds sounds like a novelty until you start mapping it onto real-world use cases. And that's where this gets genuinely interesting. Tourism and hospitality is the biggest one right now. Glamping sites, boutique hotels, and remote retreat operators love this format because they can deploy an entire cluster of guest units onto raw land in a matter of days, with none of the months-long permitting and construction timelines of traditional hotel buildings. If the business doesn't work out at that location, or the land lease ends, fold it back up and move it somewhere else. Try doing that with a poured concrete foundation. Disaster relief is another compelling angle. When you strip away the marketing gloss, a structure that ships flat, deploys in hours, and provides a code-conscious, insulated, plumbed shelter is genuinely useful in emergency response scenarios. getting people out of tents and into something closer to real housing, fast, without the years-long timeline of rebuilding permanent infrastructure. Backyard offices and guest suites are probably the most relatable use case for most viewers. Instead of a multi-month home addition project involving permits, contractors, and a torn-up backyard for a season, you're looking at a factory-built unit that arrives folded, unfolds in an afternoon, and gives you a private office, gym, or guest room without touching the structure of your existing house at all. And then there's the pure residential mobility angle. People who genuinely don't want to be tied to one plot of land for the rest of their lives. The company's own mission statement leans hard into this idea. Housing for people who are mobile, flexible, and not permanently attached to a single location. In a world where remote work has genuinely detached a huge number of people from any single office or city, a house you can pack up and take with you isn't just a novelty. For some people, it's the entire point. Now here's where this story gets bigger than just one Latvian startup and their clever hinge. Because 2026 is turning out to be a genuinely pivotal year for what designers are now calling transformative spaces. And it's not confined to tiny homes anymore. That same underlying idea that a room, a wall, or a piece of furniture shouldn't be locked into a single fixed function is showing up across the entire architecture and design industry. Developers are now incorporating movable walls into full-size residences, not just tiny homes. Furniture companies are engineering motorized tables that reconfigure themselves, revolving bookcases that rotate to reveal hidden storage or entirely new rooms, and mattresses that fold and disappear into ceilings when they're not in use. Modern apartment, a wall panel sliding open to reveal a home office that wasn't visible a moment before. And this isn't happening for aesthetics. It's happening because of something designers call spatial economics. The idea that with urban real estate getting more expensive and living spaces getting smaller almost everywhere in the world, a single room that can function as 2 or 3 different rooms throughout the day is simply more valuable than a room with one fixed purpose. A bedroom that becomes a home office. A living room that becomes a guest bedroom. A wall that isn't a wall until you need it to be. The Origami tiny home is really just the most extreme, most visually dramatic expression of a philosophy that's spreading through the entire housing and interior design world in 2026. Buildings that adapt to how people actually live, instead of forcing people to adapt to a fixed floor plan drawn up decades before they ever moved in. Architecture has spent thousands of years being fundamentally static. You build it, and it stays that way until someone tears it down. Kinematic design, origami homes, folding walls, motorized furniture represents maybe the first real, mainstream break from that assumption. The building itself is starting to behave more like a tool than a fixed object. Something you reconfigure based on what you need in that moment, rather than something you're permanently locked into. Now, because we don't do hype-only content on this channel, let's talk about where this technology still has real limits, because it does, and pretending otherwise would be doing you a disservice. First, availability. This is still a relatively small, specialized manufacturing operation, not a mass-market housing solution you can buy at scale in every country tomorrow. Lead times of 2 to 3 months, plus international shipping logistics for a folded structure, mean this isn't an instant, anywhere in the world purchase yet. Second, site requirements. No foundation doesn't mean no requirements. You still need level, accessible ground, clear vehicular access for delivery and crane work, and, depending on your location, you'll still need to navigate local building codes and permitting the same way you would for any other structure. A folding house doesn't fold its way around zoning laws. Third, and this is more of a philosophical limitation than a technical one, folding architecture is still fundamentally a niche category. It solves specific problems really well: mobility, rapid deployment, compact transport, but it's not currently positioned to replace conventional housing at scale. Think of it less as the future of all housing, and more as a powerful new tool that's opened up an entirely new category of use cases that simply didn't exist before. None of that undercuts how genuinely impressive the engineering is. It just means the honest framing here is remarkable new category of structure, not the end of traditional construction as we know it. So what happens from here? If the broader transformative spaces trend we just talked about keeps accelerating the way design analysts are currently predicting. We're likely looking at kinematic principles spreading well beyond tiny homes and boutique hospitality projects. Expect to see more collaboration between origami folding structural engineers, the same researchers working on deployable space structures and robotics, and mainstream residential architecture. Expect insulation, hinge durability, and fold cycle limits to keep improving as more companies enter this space and compete on engineering, not just novelty. And honestly, expect the price point to keep coming down. Right now, folding homes sit in an interesting middle zone. More expensive than a basic prefab shed, cheaper than a conventional stick-built home, and offering a mobility advantage neither of those alternatives can match. As manufacturing scales and more competitors enter the folding housing space, that value proposition is only going to get sharper. Wide shot, a small cluster of unfolded cabins sitting in a forest clearing at golden hour. What we're really watching here isn't just a clever product from a Latvian startup. It's an early, tangible glimpse of a genuinely different relationship between people and the buildings they live in. One where a home isn't a permanent commitment poured into the ground, but something closer to a piece of equipment. Something you can deploy, adapt, and, if your life changes, fold back up and take with you to wherever comes next. So, would you actually live in a house that folds? Would the mobility be worth trading off some of the permanence of a traditional home? Drop your honest take in the comments, because I read every single one, and I want to know if this feels like the future to you, or just a really cool niche product. If you enjoyed this deep dive, there's an entire series on this channel covering the strangest, smartest, transformative spaces being built right now. Homes that rotate with the sun, furniture that reconfigures entire rooms, structures that were never supposed to be possible with the materials we've had access to until now. Hit subscribe if you haven't already. Tap that notification bell so you don't miss the next one. And I'll see you in the next video.